The topic of this lesson is about analysis of big data on cybersecurity. First, this content introduces the purpose and necessity of the study. Second, I'll introduce big data and AI of cybersecurity. Third, I'll introduce the 3 learning modules of the study. Finally, I'll conclude on the overall cybersecurity big data analysis. We'll first introduce the purpose and necessity of the study. Cyber attacks are in increasing trend. For example, there was a cyber terrorist attack targeting major domestic financial institutions and broadcasting companies. The attack has infected a total of 32,000 PCs, making it difficult to provide normal services. Moreover, it has been reported that the resulting financial damage is also very significant. This type of attack has a large scale of damage when exposed to an attack because it systematically steals important information over a long period of time. It is difficult to detect in advance because it uses all available means such as social engineering hacking as well as malware. Organized hacker groups have been carefully and deliberately hacking certain targets. In addition, they cause social chaos through major information leaks, control system attacks, and cyber weaponization. To respond to this problem, the cybersecurity side has attempted to integrate big data analysis technology as an intelligent security technology. Cybersecurity big data has computing power that can handle large amounts of data, so it can collect and analyze attack log events and internal situation information. This big data is evolving into technology that identifies the attacker's intentions and prevents the attack from achieving its final goal. The second chapter describes big data and AI, which are the most important technologies for big data analysis on cybersecurity. Before introducing big data and AI, I would like to introduce the 4th Industrial Revolution. The 4th Industrial Revolution is the ongoing automation of traditional manufacturing and industrial practices using modern smart technologies. Large-scale machine-to-machine communication and the Internet of Things are integrated for increased automation, improved communication, and self-monitoring, and production of smart machines and can analyze and diagnose issues without the need for human intervention. The 4th Industrial Revolution consists of many components when looking closely into current social and digital trends. There are cyber physical systems, big data, AI, IoT, and so on. This is big data and AI of cybersecurity. Big data service collects, stores, processes, analyzes, and visualizes high-capacity data at velocity and delivers the required information in a timely manner. The big data architecture is an architecture that controls and efficiently manages internal and external data within an organization. It uses various ecosystems based on big data platforms such as Hadoop in large distributed computing environments using clusters. The components of big data consist of collection technology, storage technology, processing technology, analysis technology, and expression technology for the data. Collection technology is designed to collect vast amounts of big data. Collection technology-related open-source software includes Flume, Scribe, Chakwa, and Scoop. Storage technology supports key-value storage methods rather than traditional relational databases. It includes HBase, Cassandra, MongoDB, CoughDB, etc. Processing technology is important to handle big data in a timely manner. For example, MapReduce is included in processing technology. However, MapReduce supports batch processing rather than real-time processing. As a result, platform composition using Spark is emerging nowadays. Analysis technology analyzes big data, and it has detailed technologies such as data mining, machine learning, natural language processing, and social network analysis. Expression technology visualizes statistical and analytical data. R language is included in this type of technology. AI services require components in various areas, including hardware, infrastructure, frameworks, platforms, and software. AI is a field that requires complex and advanced technology, and it takes a lot of time and money to build a foundation for the AI services. This figure shows AI service technology. Building the AI service requires organic combinations and utilization of various AI technologies, which become components of the service model. As shown in the figure, the artificial intelligence market is expected to grow rapidly. In particular, cybersecurity is rapidly becoming dependent on the technology to respond to rapid and intelligent attacks. AI can strengthen its preemptive defense capabilities as well as expand its existing detection and response capabilities in cybersecurity. This is Big Data and AI of cybersecurity. Big data analysis technology, which is used in various application fields, has emerged as the biggest issue in the IT field. We define big data as a set of data that cannot be solved by the existing database processing methods, rather than just the size of data capacity. It is predicted that companies or countries with the technology or capability to process such data will become competitive in the future. The Big Data view of IDC, or International Data Corporation, a market research and consulting organization, focuses on business performance, not on database. It is defined as a next-generation technology and architecture designed to extract value from various types of large-scale data at low cost and support high-speed collection, discovery, and analysis of data. The Gartner Group, an information technology research group in the United States, defines 3 big data problems: an increase in data volume, an increase in data input or output speed, and an increase in data diversity. Although platform-based analytics such as IDS, IPS works well, they are not enough to respond to APT or advanced persistent threat attack techniques. To solve this problem, a dedicated security analysis technology is needed to analyze large amounts of data from various sources. Security Information and Event Management, or SIEM, product development is consistent with this direction. SIEM integrates equipment such as firewalls, IDS, IPS, antivirus, and statistical information and security event information from servers, network equipment, etc. SIEM provides the ability to recognize security situations, respond quickly to events, and perform log management through an analysis of the interlinkage between data. As IT and security environments become more complex, security information and event management solutions are becoming essential to the security infrastructure. SIEM will play an important role in efficient integrated log management, risk detection, incident response, forensics, and security-related compliance. This slide shows security analysis techniques using such big data as follows. The first one is real-time monitoring. Real-time monitoring is a technology that collects and manages data from various sources to record and analyze attacks on system components or to monitor user activity in applications. The second one is threat intelligence. This technology is the latest information system for various threats and attack patterns that make abnormal activities more recognizable. For example, if a small amount of outbound traffic to an external IP can be disguised as normal traffic and overlooked, this is perceived as threat information related to attack control. The third one is behavior profiling. This technique defines associated rules to find a series of specific conditions when conditions for abnormalities are well defined. In addition, since it is difficult to detect all abnormal behaviors with the rule-based methodology of the technology, behavior profiling-based abnormality is detected. The fourth one is data and user monitoring. Monitoring user activity and data, including user and data context, are essential to detect penetration and misuse. It requires essentially monitoring privileged users and sensitive data access. The fifth one is application monitoring. This is the activity monitoring technology of abnormal applications, as it is the main target of targeted attacks in analyzing vulnerabilities in applications. The sixth one is analytics. It is a key technology of big data security analysis that analyzes the characteristics of various source information by utilizing machine learning, data mining, and network mining techniques, which are traditional methodologies of big data analysis, and determines whether there are any abnormalities. This figure shows statistics related to big data cybersecurity surveyed by the Ponemon Institute in 2020. We can note that big data is one of the meaningful sources in cybersecurity. Big data applications related to cybersecurity include the information marketplace for policy and analysis of cyber risk and trust or impact. With the support of the U.S. Department of Homeland Security, Impact shares more than a petabyte of data needed for cybersecurity research. It provides services such as data retrieval, data analysis tools, matching data sharing. The slide shows the Impact website. In this chapter, I'll introduce 3 study modules. Cyber battlefields are defined and various countermeasures are being taken to cope with the exponential increase in cyber attacks worldwide. Despite the significant increase in interest in cybersecurity, it is increasingly important to analyze the cybersecurity big data and utilize AI services due to the lack of specialized personnel. This figure shows our study modules, including Big Data on Cybersecurity, AI, including machine learning, deep learning, and cybersecurity's final goal. This chapter will explain the importance of the Big Data on Cybersecurity and AI in each of the sections below from a cybersecurity perspective. This slide introduces the first study module case study of Big Data on Cybersecurity. Website defacement is usually used with attacks of hacktivism, phishing, and pharming. The hacking attacks mostly on the web and website tampering continues to increase. Over the past 3 years, the number of hacking attacks on websites has increased by more than 60% every year. The attacks are changing from defacing-oriented to profit-seeking, such as malware injection. Therefore, it is necessary to detect real-time website tampering using AI-based monitoring systems. This figure shows normal and defaced websites. The goal of machine learning-based website defacement detection is to automatically identify the hacking of collected websites through intelligent web crawler. This detection system forwards identification results to control center. First function extracts image objects from websites from a learning model and identifying website defacement. Second function determines the modulating similarities of the website through the learning model. Third function verifies results of the learning model and converting advanced analytics. This slide describes the data definition. There are 4 types of data for website defacement detection. Image data within the website should be analyzed. Variables include image patterns, hacking messages, etc. Learning results are divided into hacking messages and hacking image patterns. The analysis results print similarities with the learned hacking image. The data is divided into training data and test data. 800 are divided into learning data and 200 are divided into test data. An analyst checks learning data and labels hacking type tagging. A developer learns the model developed through 800 data and verifies the model through 200 data. AI models that have been developed will be checked for hacking through the analyst. This slide shows pictures of pre-processed plans. Labeling program is used to label parts of the hacked website image. This detection system uses OCR in hacked images to extract hacking-related sentences and store the information. The system uses the information to classify images. Extracted data is stored in a dataset, separating the text from the image. If the variable x1 is hacked by, change x1 value to 1 from 0 in the dataset and output the result as website defacement. In addition, if an image of h1 is extracted, then the h2 is tagged to 1 in the dataset and the result is printed as website defacement. The expected effects of the website defacement detection model are to reduce the workload of modulation verification and analysis response time by utilizing AI, to promptly notify the modulation alarms through its hacking monitoring, and to promptly and accurately take measures against the rapidly increasing threat of infringement, and to predict and prevent large-scale damage caused by cyber attacks. Recently, web infringement incidents has increased rapidly. The increased incidents have made limitations in analysis work and manpower. To address this issue, it is necessary to automatically perform the big data analysis using machine learning. The goal of web infringement incident analysis is the establishment of an adaptive security system based on AI for reducing processing time of the data analysis. This figure shows process of extracting URI of web log, identifying hacking, creates its learning model. It analyzes the cause of hacking incidents, determines the classification, and decides threat of infringement through AI learning. AI learning data uses information extracted from the big data, such as client IP, remote identification, username, connection time, request type, URL, protocol version, status code, transmission data size, and so on. Then, the features are extracted from the data analysis, such as IP count. The analysis from learning is classified into 3 types: SQL injection, shell execution, CNC communication. At this time, we'll focus on the SQL injection attack. The machine learning learns patterns of the abnormal big data, extracts the data of similar patterns, and provides them to analysts. The web infringement incidents analysis learns 3 types of abnormal log using log filters in the access log file after extracting and pre-processing the log information. The abnormal log is analyzed to retrieve the relevant information from the Elasticsearch DB. The normal and abnormal data are classified for relearning in the future and improving accuracy. In data definition, web access log files are analyzed. It is parse web log files into log filter and classify log information into normal and abnormal logs. In collection of learning data, a collector accesses log files of web servers related to infringement incidents and classifies abnormal log patterns in access log files. The third phase is pre-processing data for analysis. It extracts detailed information of the access log file to the grok, which is one of the log filters. This table is an example of pattern for SQL injection. This is data extraction module for log filter. This module's input is access log. Its filter module extracts data using pattern matching. Its output is log details and JSON files for search. The 5th phase is feature data generation. To extract data of SQL injection, the system needs to get request type, subquery, and status code. This figure is an example of an extraction of SQL injection pattern. To detect SQL injection attacks, the system extracts meaningful query information, such as select, onHex, semi-round bracket, hex, semi-round bracket, cast. Thus, the model can use secure big data to analyze web infringement incident. The expected effects of the web infringement incidents analysis model take prompt and accurate action against the rapidly increasing threat of infringement. It can then predict and prevent massive damages from cyber attacks. In particular, The web analysis of infringement incidents also reduces the time required to process cases than extracting attack types from large logarithms, million cases. This model extends to firewall log collection and allows further analysis of source IP, destination port, and session. This slide introduces representative big data analysis products. IBM's QRadar, an all-in-one solution. This solution provides the collection of various sources and the analysis of the behavior of the network and the application layer. It is possible to analyze network flow data processing and precision analysis, including event collected from the source. It also offers solutions to security incidents, such as the penetration of new viruses into corporate internal systems, information leakage, and forgery. McAfee acquired Nitro Security to enter the market of Big Data On Security. McAfee Enterprise Security Management, or ESM, is an appliance that integrates Security Information Management, or SIM, and Security Event Management, or SEM functions that perform inline network monitoring. This product performs a Deep Packet Inspection, DPI function, to obtain application context and content for data and security events. Integrated Security Management function is provided to collect event information and security information and analyze associations. HP ArcSight SIEM platform is an integrated security control product for collecting, analyzing, and evaluating security and risk information. In addition, the Oracle database is replaced in part by a correlation optimization, storage, and search engine, providing simplified DB engines for its small and medium customers. The ArcSight platform is an integrated system for collecting, analyzing, and managing enterprise event information. The platform provides the ability to regularize event information collected from various sensors into a single structured format for efficient search, correlation analysis, and statistical reporting. Splunk is mostly applied to IT operations and application support to provide availability-oriented log management and analytics. In addition, the product provides real-time Splunk interrelationships and Splunk applications to provide predefined functions to support enterprise security monitoring and analysis, use cases, and more. Through integration with SIEM products, Splunk provides complete monitoring of enterprise infrastructure and provides a structure that processes some of the information in conjunction with SIEM for deep association analysis. This slide introduces second study model, a study on security big data analysis based on machine learning. The traditional programming procedure starts with entering data into a program. Then the program processes calculation and produces results. It is a science and technology that studies systems that improve the performance of itself from empirical data based on environment and interaction. Unlike traditional programming procedures, when data and target results are entered, the results can be obtained from machine learning algorithms. Machine learning refers to a series of tasks that teach machines. This machine learning is necessary to have enough data to efficiently draw the right conclusions through repetitive learning. There are two key elements in machine learning. Big images data set must be presented to enable machine learning. Machine learning refers to the collection of numerous examples as data. Labels is to giving a random image and affixing a mark to indicate its identity. The basic algorithm of machine learning is to infer information about data properties using a given data set. Machine learning models can be divided by parts, data acquisition methods, model structure, and learning algorithms. The data are classified into training data and actual data, and the training data creates machine learning models through machine learning algorithm. Since the late 1990s, infectious methods and symptoms of malignant cause have diversified. As the use of personal computers has increased, malware has also increased rapidly. The development of computers and the evolution of malware are very closely related. In the days when there were many illegal copying, malwares were suitable for propagation through storage media through illegal disk cloning. As the high-speed internet appeared and the numbers of users increased, malwares propagated to email where the web increased rapidly. Malware is a general term for all software that can have malicious effects on personal computers. The first known case of malware to infect end users was 1985 under the guise of normal open software via the Bulletin Board System, or BBS. Trojan horse is a general camouflage technique including malicious routines such as a program virus or worm. Virus is code that sneaks into the computer system and infects the target. Worm is self-replicating, self-executing, destroying other programs. Spyware is software that intrudes into someone else's computer to steal personal information or to be used for advertising. Malicious bot is a program which handles users' computer. Rootkit is a malware that obtains administrator rights on the computer and hides itself from the operating system or other programs. Stuxnet is a malware designed for industrial automation control system. Backdoor is a tool to help hacker to gain access of the system without proper procedures. Keylogger monitors and records inputs from the keyboard and sends them to the attacker. Adware is installed when surfing the web and exposes advertising via pop-up windows, etc. Ransomware is a program that induces individuals or enterprises to execute scripts using social engineering methods as targets to encrypt all documents and induce money or Bitcoin in exchange for decryption. Static analysis refers to checking the internal code and structure using a disassembling or identifying the behavior through header information, internal strings, execution compression, and registration information without executing malware. Before dynamic analysis, the static analysis technology is required to collect malware information first. There are 5 general static analysis of malware. There are PE structural analysis tool, resource analysis tool, hex code analysis tool, string extraction tool, disassembler. Dynamic analysis refers to analyzing the behavior by executing the file directly and checking the code flow and memory status directly through debugging. There are 6 typical dynamic analysis of malware. They are process analysis tool, registry analysis tool, network analysis tool, file system analysis tool, disassembler, API call relational analysis tool. This figure shows Kaspersky's machine learning-based malware detection strategy. As shown at the bottom of the figure, it is divided into 2 main parts. The first part is the large classification of malware, and the second part is carried out only for files that are not clearly identified in the first stage. What's interesting is that there are groups formed by files that are difficult to identify, and when you learn machine learning models for each group, you'll learn about the malware of the group and the entire normal file. One of the most frequently referenced malware datasets is the 2015 Kaggle competition held by Microsoft. Disassembly and bytecodes are provided from 20,000 samples of malware, total 0.5 terabytes. The malware sample has a value of one of the 9 labels. It is a multi-class competition for a given sample of malware. Header information is deleted to prevent malware from actually operating. A team of data analysts with no security expertise in the Microsoft competition, achieving 99.83 accuracies. This figure shows the features and models used by the winning team. The program's main functions were imaging the opcode engram, segment count in assembly code, and obtaining the pixel intensity. These were used in the machine learning model with 3 XGBoost and applied ensembles. The top 3 teams in the competition all used XGBoost. The XGBoost model has proven to be the best suited for limited data sets and high accuracy over time. In fact, the boosting models are doing well in other data analytics competitions. The random forest is similar to boosting family, for example, XGBoost, LightGBM, etc., since RF uses many weak classifiers in parallel to reduce variance and increase accuracy by sampling variables and data in a bagging method. However, by applying the classifier, it will be more accurate than the real. Let's learn more about other issues in the previous classifier. This figure overviews of machine learning-based malware analysis. The goal of malware analysis is to learn the results of CTAS malware artifact analysis based on AI and provide answers to malware artifact behavior questions from information sharing member companies. 5 types of malware artifact behavior should be tagged to create a learning model: registry, auto-run path, background, service path, file path. The results of malware artifact behavior are analyzed with AI to classify abnormal events to 5 patterns: non-classified queries, and queries with low malware probabilities carry out further detailed analysis by the analyst. On behalf of the analyst, AI learns the results of 5 types of malware artifacts, and the analyst focuses on verification and detailed analysis of the results of the learning model to enhance and specialize in work efficiency. This system classifies patterns related to malware artifact behavior in CTAS-DB, accumulated in big data, and AI learns through MLP. When an external CTAS user queries the results of malware artifact behavior, it extracts the contents of the query and the characteristics of attachments suspected of malware. A probability indicates the probability of malware presentation compared to the pattern of characteristics learned in AI analysis system. Non-classified queries and queries with low malware probability carry out further detailed analysis by the analyst. In data definition, analysis data is malware artifacts behavior query of CTAS users. Independent variables are malware artifact behavior characteristics information. Learning result is malware artifact behavior pattern. This table shows an example of data for learning. This is a method for collecting data for learning. The collecting data is malware artifact behavior information. The data has 5 attributes: registry, auto-run path, service path, file path, execution path. There is pre-processing plan for learning. It converts malware artifact behavior information registered in CTAS into numeric columns and analyzes features. This figure shows big data analysis expansion data pre-processing method for learning pattern learning method. This method makes pattern extraction of malicious code characteristics, runs pre-processes, and learns a model after mapping each numeric value to one input node. There is a data pre-processing plan for analysis. It converts string information from malware artifacts to numeric columns during a CTAS user query, and extracted strings to 200-byte numeric columns. The expected effects are based on AI to learn the results of CTAS malware characteristics analysis. It overcomes the limitations of responding to the latest malicious behavior, as new attacks increase more than the speed at which security policies are updated. This slide introduces third study module security technology research using deep learning. Deep learning, a model evolved from machine learning, is an artificial intelligence technology that allows computers to learn like humans by combining more active unsupervised learning with existing supervised learning that requires human intervention. This slide shows the structure of a deep learning neural network in which the input layer and the output layer are connected through a hidden layer. Artificial intelligence technology is affecting all industries by advancing rapidly. In particular, in cybersecurity, dependence on AI technology is rapidly increasing to respond to rapid and intelligent attacks. AI can improve existing detection and response capabilities in cybersecurity, as well as strengthen proactive defense capabilities. We'll address the principle of deep learning with the 10 keywords. There are supervised learning, unsupervised learning, regression, classification, clustering, linear regression, loss function, gradient descent, LMS or least mean square, and reinforcement learning. Supervised learning is the machine learning task of learning a function that maps an input to an output based on training input-output pairs. It infers a function from labeled training data consisting of a set of training examples. In supervised learning, each example is a pair consisting of an input object, typically a vector, and a desired output value, also called a supervisory signal. A supervised learning algorithm analyzes the training data and produces an inferred function, which can be used for mapping new examples. An optimal scenario will allow for the algorithm to correctly determine the class labels for unseen instances. This requires the learning algorithm to generalize from the training data to unseen situations in a reasonable way. Unsupervised learning, also known as self-organization. Unsupervised learning is a type of machine learning that looks for previously undetected patterns in a data set with no pre-existing labels and with a minimum of human supervision. It works for modeling of probability densities over inputs. As shown in left, regression learns using training data, which is an input value x and label t. Then, it predicts a corresponding value when an unknown input value is given. For this, a linear regression model is used. This figure is an example of a regression predicting a test score. As shown in the right, classification is learning using training data, which is an input value x and label t. Then, when an unknown input value is given, it determines which label this input belongs to. Since both classification and regression are supervised learning models, they have in common that they learn from labeled input data. The difference between classification and regression is that the result of regression can be any value within the range of the data set, and result of classification is one of the fixed labels. This figure is an example of a classification predicting pass or fail. Clustering is a representative model of unsupervised learning. It extracts the summary information of an unlabeled data set and extracts the features of the entire data set through this summary information. K-means clustering is a representative algorithm of clustering. K-means clustering aims to partition an observations into K-cluster in which each observation belongs to the cluster with the nearest mean. Linear regression is a linear approach to modeling the relationship between a scalar response or dependent variable and one or more explanatory variables or independent variables. In linear regression, the relationships are modeled using linear predictor functions, which unknown model parameters are estimated from the data. The loss function or cost function is expressed as a formula by adding the difference between the correct answer, t of the training data, and the calculated value y of the input x. If you add up all of the errors to get the loss function, the sum of the errors may be 0 because there are both plus and minus errors. So, when calculating the error from the loss function, use sum of squared error. T minus y caret 2 equals t minus wx plus b square root. In this case, the arrow is always positive. Moreover, since it is squared, if the difference between the correct answer and the calculated value is large, the arrow has a larger value by the square. A small loss function means that the average error between the correct answer and the guess value is small. The small mean error means that given the unknown data x, we can probabilistically infer that the future result will also have a small error. As such, the final goal of the regression model is to find a model so that the loss function has the minimum value based on the training data. Finding the model with the minimum loss function value is the final goal of the regression model. The gradient descent algorithm meets this goal. This figure shows an example where the loss function is minimal. When the y-axis is the loss function value, the minimum loss function is when w is 1. And based on w equals 1, you can see that the loss function value continues to decrease as w equals minus 1 approaches w equals 1. Also, it can be seen that the loss function value continues to decrease while approaching w equals 1 from w equals 3. The least mean square method is finding the least mean square of the error value, difference between the desired and the actual value. Using the square of the arrow, the difference between the predicted value and the actual value as the objective function. It increases or decreases by the slope of the objective function from the initially predicted value and approaches to the local minimum value of the objective function and finds a solution that becomes a minimum value. Reinforcement learning is an area of machine learning concerned with how software agents ought to take actions in an environment in order to maximize the notion of cumulative reward. Reinforcement learning is one of the three basic machine learning paradigms alongside supervised learning and unsupervised learning. Reinforcement learning differs from supervised learning in not needing labeled input or output pairs be presented, and in not needing suboptimal actions to be explicitly corrected. Instead, the focus is on finding a balance between exploration of uncharted territory and exploitation of current knowledge. The OR problem has the following results for two given inputs as shown on the left. When one input is 0 and the other is 0, the result is 0. When one input is 0 and the other is 1, the result is 1, and etc. An AND problem, as shown in the middle, has the following results for two given inputs. When one input is 0 and the other is 0, the result is 0, and etc. The OR problem has a red dotted linear equation that can classify plus means value 1, and minus means value 0. This means that the OR problem can be solved by machine learning techniques using linear equations. Likewise, the AND problem can be solved with machine learning techniques. The XOR problem has the following output values for two given inputs. When one input is 0 and the other is 0, the result is 0, etc. By the way, in the XOR problem, there is no single linear equation to classify the result. Instead, it can be solved using two linear equations, which means the problem cannot be solved with linear regression. One way to implement the XOR problem is to use a deep learning architecture consisting of an input layer, a hidden layer, and an output layer as shown in the figure. As explained earlier in deep learning, it has one or more hidden layers. In this case, one hidden layer exists. AlphaGo is a computer program that plays the board game Go. It was developed by DeepMind Technologies, which was later acquired by Google. This figure shows a schematic representation of the neural network architecture used in AlphaGo. AlphaGo uses a policy network and a value network. Policy network takes a representation of the board position as its input and outputs a probability distribution over legal moves. Value network similarly uses many convolutional layers with parameters. Here, convolutional layer is a main keyword in deep learning. You can check it later by your own. Among companies researching cybersecurity using deep learning, Deep Instinct was founded in 2015. Deep Instinct says the benefits of applying deep learning to cybersecurity include raw data training, independent of human intervention, analysis of all types of data, nonlinear correlation, unlimited training samples. Using deep looping in any environment, anywhere, any operating system, any attack, companies can respond immediately in zero time. Let me conclude. Cyberterrorism causes social chaos and threatens national security. It is necessary to apply intelligent security technologies since cyber attacks become more intelligent. 3 learning modules were introduced for active cybersecurity technology. There are case studies based on security big data, a study on cybersecurity analysis based on machine learning, and a study on cybersecurity analysis based on deep learning.